Hello class, welcome to our second portion of section 2.4, dealing with solving right triangles. Today's focus is more on application and word problems. Some of the questions that we're going to look at are from your textbook, so if you have that, you'll want to probably be referencing it as we go through. I'm just going to go through a few of those questions from the textbook that should correlate decently to your homework. Obviously, there's some other questions that you can look at, and I'll have those in the notes and kind of at the end of the lesson. In order for you to be more successful and hopefully more comfortable with some of these word problems in real world examples. Just some general strategies to make sure you have figured out on these questions. Some have pictures and others don't. So if there's not a picture drawn, you might want to draw it. Make sure you label the pieces accordingly. Remember, when you're solving pieces from these questions, you typically aren't solving the whole triangle like what you did on the previous lesson. You're typically only finding one spot. Now, it might require more than one piece to be found, but typically you don't have to solve every part of the triangle to do that. The other thing to keep in mind is angle of elevation and depression. Angle of elevation is from the ground upward, so like letter A is an angle of elevation. Angle of depression is from the sky downward. What you'll notice here is that these are kind of alternate interior angles for this situation. Just make sure that you're looking at the angle of depression correctly, because it's not down here. It's actually from the skyward downward. So just some things to keep in mind in general strategies for these questions. Okay, this question should correlate to number 46 in section 2.4. There's actually a picture in your textbook that correlates to most of these, so you might want to look at that as you're going through. I'm going to go off of the assumption that there's not a picture, just so we can see how to set it up. One thing about all these questions is you could probably make a right triangle and use that, because everything here is going to be a right triangle for trigonometry right now. And so to find the distance RS across the lake, okay, the idea is you can't really measure across the lake. Obviously now with satellite imaging, that stuff has become a lot easier. But the idea of surveying and looking at land and those type of things is still used today for certain aspects. It says that the surveyor goes from the one side of the lake and goes straight out, okay, 53.1 meters, and the angle that's created for this triangle is 32 degrees 10 minutes, and they tell you angle S is 57.50, and you're trying to find the length of RS, which I'm denoting the letter T because it's opposite of angle T. And then you can just set it up using either angle. So I'm going to use the 32 degrees. So tangent of 32 degrees 10 minutes would be T over 51.3, and I cross multiply or just multiply the 53.1 to the other side, and I should get 33.4 meters. You want to make sure that you're able to get that. Try those out. Make sure you know what you're looking for when it comes to these scenarios. Okay, especially plugging in degrees and minutes. So just make sure that you're able to plug everything in and find the answers to those scenarios. So just be cautious on that. But that's a fairly simple example of using a right triangle to find a missing piece. The next question deals with the altitude of an isosceles triangle. The key with isosceles triangle questions is whatever number they give you typically has to be cut in half. For example, they say the base is 184.2. That's this whole distance, but that's not a right triangle. So the right triangle is half of that because it's an isosceles. So divide by 2 would give you 92.1. And it says the side opposite of the base. So if the base is here, the side opposite, this one at the top, would be 68 degrees 44 minutes. You've got to cut that in half because you only have half of it for the right triangle. From there, I'm trying to find the altitude, which I denoted with the letter A for altitude. Really doesn't matter which one you pick. Tangent of 34.22 would be opposite, 92.1, divided by adjacent. Remember, this is different than the last slide. So on the last slide, we just multiplied the denominator to the other side and found the answer. On this question, you're going to have to multiply A to the other side and then divide by the tangent piece to get rid of it to find your answer of 134.68. The isosceles triangle question, there's going to be a right triangle somewhere in it. Okay, so for this scenario, it's the idea that there's half of those pieces and then you make a right triangle out of it. It's a nice benefit right now knowing that there has to be right triangles involved, because everything that you've learned about trigonometry is based on a right triangle. Okay, the next question has a lot of information, so I'll try to make sure I explain where all these pieces are coming from. This says angle of elevation from the top of a small building. So think about you're standing at the top of this building. So just draw kind of a horizontal because that's where you are. So the angle of elevation is going upward from there, 46 degrees, 40 minutes, to the top of another building. And it says if you were standing at the top of that building, the angle of depression, so from that line downward, okay, towards the bottom of the building, is 14 degrees 10 minutes. Now my picture is not drawn to scale at all. The top part's clearly taller because of the angle being much bigger, but you can still get the basic idea and understanding of what you're supposed to be looking at. They tell you the height of the small building is 28 meters. That also corresponds to this piece right here being 28 because it kind of makes this rectangle shape. Obviously, if I was better at drawing or spent a little bit more time, it would be a perfect rectangle. But hopefully that makes sense where that piece is coming from. And then what you have to do here is you really can't find this y value yet. You have to use this right triangle at the bottom, okay? And I denoted to solve for x. So to solve for x, I'm going to use tangent again because tangent of 14 degrees 10 minutes would be opposite over adjacent. And check that out. Make sure you can get to an answer of 110.926. Make sure you try that out and find it. And then you have to use that number in the next piece, which is this right triangle at the top. And again, I would use tangent. It's not always going to be tangent, but it tends to show up a lot of times unless there's a slant or diagonal height given to you. So that's something to keep in mind. So for this question, tangent of 46 degrees 40 minutes would be opposite, which is y, divided by adjacent, which was your new x value you just found. Pay attention to what you're rounding the final answer to. Whatever you're rounding to in that question, you want to have more decimal places for the x in the middle of the question. Because tangent and sine and cosine trig functions are really particular and really small numbers, and a slight change will really affect big numbers with the side lengths. So you want to make sure you're as accurate as possible. The other key piece to this question is once you solve for y, so you kind of go through two triangles and solve for y. That's not the answer. That's just from your height to the top. So you have to make sure you add the height of the original 28 or the small building, and that will be your final answer. So this question takes a decent amount of work and steps. You want to make sure that you understand where they come from and how to find them, and you can use that to hopefully answer your questions. Okay, this one just has a quick review. Similar to the last one, I kind of left the round to the nearest minutes to you, or nearest 10 minutes to you. I wanted to focus on the fact that this is secant. So secant, remember, is the reciprocal of cosine. So it's negative in 2 and 3 because cosine's negative in 2 and 3. I do cosine inverse, remember, of this ratio to find the angle. Quadrant 2 is the weird one. Quadrant 2 gives you the actual answer of 113.1, but remember, you need the reference angle to find the other answer. And the reference angle here would be 66.9. And then you plug that into quadrant 3, and 180 plus the 66.9 would be 246.9. Those are your two answers. Now, these are degrees decimal. Remember, if a question says round to the nearest 10 minutes, you have to make sure you switch it using DMS on your calculator. Make sure you're able to do that and round to the nearest 10 minutes. Okay, that's all of the information I was going to kind of say to the whole class. What you want to look at now is questions 45 through 60 on page 79 in that section 2.4. You want to try out some of those different questions to make sure you're ready for the assessment and for your homework. I know it's tempting to just say, oh, I don't need to do any of those and kind of move on, but those questions will really prepare any situation about solving right triangles. And here are some of the answers. I know I'm covered up here for part of it, so let's get rid of me here. There we go. So here are all the different answers to those questions. If you have any issues on these as you're going through, please let me know or reach out to another student. These questions, you want to make sure that you can understand where they're coming from and how to set them up. So if you have any issues, let us know, and we'll be happy to kind of discuss some things about it. Otherwise, make sure you're working on your homework questions to get ready for the next test. Have a good day, everybody.